Continue curve sketching. Let's take a look at this function, okay? Y equals to x log x. Now the domain is a positive value, right? X cannot be negative. So this is the domain. And first derivative, that's the first derivative. So from this derivative, we know that function is the derivative. The first derivative is negative when x is less than 1 over e. At 0, well, the first derivative is equal to 0 when x equal to 1 over e. And the first derivative positive when x is bigger than that. Okay, these are the subinterval, you know, over which we know the shape of curve. You know, increasing, decreasing, and so on. Now the second derivative is the derivative of this, which is always positive, right? Always positive. That means the function is look like this. See, from this is a turning point. So from this x equal to this number, y is equal to, you replace x by 1 over e, and then y is equal to negative 1 over e. So when x equal to 1 over e, y equal to negative 1 over e. Right? So this is negative 1 over e. This is 1 over e. So this is the point, the function passing through. At 1, y equals 0. At 1 it was here. So at 1, this is 1. This is y equal to 0. They're passing through. Now, also, at 0, the function is not defined, but the limit does. The limit does exist. We take the limit, use the L'Hopital's rule. No? I'm not to spend time here. You know how to find this limit, which is equal to 1. So it means that the function does not define at 1, but the limit does. So there's a hole here. The function is not defined there. It defines there. Okay. Then x before 1 over e is increasing, or is decreasing, huh? So decreasing. After this point is increasing and crossing this point, right? Crossing this point. So that's the curve. Don't forget there's a hole here. That means the function is not defined at 0. You see, we can check easily. Second derivative is positive. Second derivative is positive. See, the shape look like this. And decreasing. After this point, increasing. Okay, let's consider next example. This one. This function, obviously that x is positive, right? X cannot be 0. Is that 0 is not defined. That's the domain. Now then, the first derivative, quotient rule. After that, simplifying, you get this function as first derivative, from which we know that this is a positive when x is less than e. This is negative of x is greater than e. At x equal to e, this will be 0. So obviously, this will be our maximum. Right? and take the limit x approaches to infinity, because this one, when x approaches to infinity, this one is approaches to 0. So this is the asymptote, from above. Okay. In the second derivative, we take this function, the derivative again, then we simplify. After that, we get this one. This one will be negative then when x is less than e to the power 3/2. Well, a little algebra there, you can verify by yourself. And at this point, the second derivative will be 0. That is a point inflection. Now then x greater than that, the second derivative is positive. Now these are just simple algebra, I don't want to spend time to do the detail, but the result is, all listed here. Now when x is approaching to positive infinity, this is a negative infinity by taking limit, right? So that means x approaches to 0 from here. This is a negative. That's asymptote. Now then we pick up a special point. When x is equal to e, you put it here, y equal to 1 over e. So when x is the e, okay, this one is, this height is 1 over e. Then another point is important. This point, this is e to the 3/2. We put x equal e to 3/2. We can calculate y. Y is this value, right? Simply put this x value there. When that is height. This height is this. Okay. At 1, when x equal to 1, this is 0, right? This is 1 is 0. So this is the point passing through, asymptote. Then we can sketch the curve. Right? The curve is okay. Then decreasing like this, then point inflection, asymptote. Well, it's very, very nice picture. Now we can check easily to each subinterval the signs of derivatives, and they satisfy these two pictures. Okay. So one more example. Y equals to x over log x. Now obviously that x is positive, x not equal to 1, right? Now then the first derivative, well, I save time by using quotient rule, then simplify. And from this we can analyze the signs of a derivative. When x less than e, that's negative. When x is greater than e, is positive. At e, first derivative is 0. So from this point, we can find y. So this may be a maximum or minimum. Then we take the second derivative. Now I save time that just do the derivative again and simplify. You get this. And from this, we can analyze the sign. When x less than 1 is a negative, well, because this one, because the denominator. Now, when x between 1 and the e square is positive. This is positive. And when x is bigger than e square, this will be negative again. Now you can just check it because I don't want to spend much time for those details, And when second derivative is 0, this may be point inflection, so we can find a y when x equals to e squared. Then also we find the limit when x approaches to 0. This function, the limit equals 0 by using L'Hopital's rule. So the limit, the function is not defined at a 0, but the limit it does. This is a hole here. Okay, then when x approaches to 1 from right hand side is in positive infinity, that is this asymptote, right? When x approaches to 1 from left, that is negative infinity, so that is this. Then joining these information and also by consider the special point x equal to e, y equal to e. This is the one, right? This is e, yeah. This is e. Y equals e. This is e square. And y is equal to e square over half, somewhere here. Okay, the point is there. So this is these are special point and asymptote to consider. Then we join the curve. Okay, first derivative is negative, is decreasing. And this is 0, which means the minimum. Then increasing after e, right? Increasing after e. After e square, the second derivative is negative. So the curve will look like this. See, first derivative is positive, second derivative is negative. So it goes like this. So that is the curve of the function. And we can check, carefully about the derivative. The derivative is decreasing. First derivative is decreasing. Second derivative is negative. Negative. So this is the curve. This is the curve. Then function is decreasing before e. There's decreasing again. But the second derivative is positive. So this is the shape. This is the shape. Until x equal to e square, until this point, the second derivative will be negative again. So negative again. So that's the shape. Okay. So these are very nice way of sketching a curve by using the derivative, the asymptotes, and special point, and so on. Okay. Now I don't want to put too many examples in one episode, so that's enough for today's, and we will see you next time again. Thank you for watching.